Click pins. You click them on, you click them off. How do they work? And what creates that distinctive click? There are many types of click-to-write pens. A simple latch mechanism locks this ink cartridge in place. It's released by pressing a button. And in this pen, an angled tooth cam locks or releases the ink cartridge. And here, a triangular cam that tilts from side to side to lock and release the cartridge. In this video, I detail the operation of this pen, a Parker Jotter introduced in 1954. It's one of the first retractable pens. Now listen carefully and you'll notice that it emits 4 clicks. A click when I push the button, a second click when I release it, and then when I push the button to retract the ink cartridge, a third click, and release, a fourth click. To understand why these clicks occur, let's look inside. The pen's barrel houses an ink cartridge with a ballpoint tip, 2 springs, one at the top and one at the bottom, and a plastic tube which is press fit inside the metal barrel of the pen so that it's fixed in place. Inside that tube is where all the action happens. A Parker Pen Company patent describes the 3 parts that produce the pen's click: the cam body, the tubular plunger, and the stop members. The cam body is affixed to the top of the replaceable ink cartridge. During operation, this cam body rotates and slides up and down. The tubular plunger does not rotate. It only slides up and down. The stop members are shown as separate pieces here, but keep in mind they're part of the press-fit plastic tube and so never move. The pen can be in either of 2 positions: the retracted non-writing position where the tip of the cartridge is inside the barrel, or in the extended writing position where the cartridge's tip projects from the barrel. To see how the plunger, cam body, and stop members interact, I've broken the cam movements into 8 steps. First, push the button to drive the plunger and the cam body down the barrel until the top of the cam body drops below the fixed stop members. Second, remember that the spring at the bottom of the pen pushes the cam body up and so keeps it in contact with the plunger. That axial spring force shoves the cam body up the barrel, but also rotates the cam body because it mates with the plunger at an angle. The cam body rotates 45 degrees until it strikes the surface of the plunger. That very fast motion creates the first click. Third, I release the button and a spring between the plastic tube and the lip of the plunger forces it to the top of the pen. When the tips of the plunger's fingers clear the cam body rotates another 45 degrees until it strikes the blue stop members. That's the second click of the pen. Fourth, I release the button completely, and now the cam body remains locked in place. It cannot rotate nor move upward, and so the pen is ready to write. To retract the pen, I press the button to drive the plunger into the cam body and to push it past the stop members. The cam body rotates until it strikes the plunger. That's the third click. I release the button so the top spring forces the plunger upward. When the plunger fingers clear the cam body, it slides and rotates 45 degrees until it strikes into the stop members. That's the fourth click. Once the button is completely released, stop members slot into the cam body so that when the plunger moves up, the cam body moves with it to retract the ink cartridge. In extending and retracting the ink cartridge, the cam body rotates 45 degrees 4 times, or 180 degrees total. The cam body has 180-degree rotational symmetry, so that the next extend retract cycle repeats the same sequence of steps. This particular model of pen has sold over 750 million units since its debut. It took a team of 66 people to design this pen, and although it's a mechanical marvel, the Parker Company worried that this retractable ballpoint ink pen would damage their reputation. Parker pens were fountain pens. And so the company left off their iconic arrow clip. But within 4 years, the pen earned its arrow and inspired other pen makers to design click and lock mechanisms, all different to avoid patent infringement. The clicking of a pen demonstrates how a single engineering problem can have many engineering solutions, ranging from robust to cost-efficient to unique. I'm Bill Hammack, the Engineer Guy. Subscribe to the channel for more engineering videos.
And if you want to help us make better videos, become an advanced viewer. Go to engineerguy.com/preview to sign up. Our advanced viewers help us refine the draft of this video into a much better product.
We greatly appreciate all the responses. Thanks.